Hey, what's going on, guys? Let's do this problem right here. The question is asking, using the cross-section method, find the volume of the solid obtained by rotating the region bounded by y square is equal to x and x is equal to 2y about the y-axis. So here they are telling that this cross-section method, this is same as dish-and-washer method. So in dish-and-washer method, then whenever they say it's rotating about y-axis, it's going to be dy. But in cylindrical cell method, if it's y-axis, it's going to be dx, right? So here it's better to keep everything in terms of dy. If it's cylindrical cell method, we better change everything in terms of x, right? So so here, since everything is going to be dy, it's not a problem because we have x is equal to y square. That's what we want. So that's not a problem. Let's go ahead and draw the graph for these functions first. So first we have x is equal to y square. So this is going to be opening to the right side, because if you see, when y is equal to x square, we know that this is a parabola opening up, and we know that this parabola going in the positive y values. So here this goes to the x values. So when x is equal to y square, this goes toward the positive x values, and this open toward the right. So that's the relationship. And then here again we have x is equal to 2y. When y is equal to 2x, we know that's a straight line going toward the positive x values, and here same thing. Here it's going to go toward the positive y values. So if you draw a line, it's going to go toward the positive y values and cross like this, right? So this is the region we are interested in. This is the volume of the region we are trying to find. Since we are doing, so let's try the equation first. So we know that for a cross-section method, we use this one. This equation: a is equal to phi integral r out square, radius out square, minus r in square. Since this is rotating about y-axis, we have to keep everything in terms of y, right? So since this is in the y-axis, we have to get the limits of integration in the y-axis. So we know that this is starting from 0. We can find it from the equation. If you see that we don't have any shift, we don't have any plus or minus sign, so we don't have any shift right here. And to find the other one, we have to find this one too, right? To find this one, what we have to do, we just equate these y values. So here, if we equate, let's see what we get. So we have y square in the first function, and the second function we have 2y. Let's bring them together. So this is going to be y square minus 2y is equal to 0. If I take y common, this is going to be y minus 2 equal to 0. So from this one we know that this is going to be 0 and this is 2. So it's going from 0 to 2. So this is going to be 2. So our limits of integration is going to be 0 to 2, right? Now we have to find the r out and r in. When we had, in terms of, like, if it's rotated around x-axis, we know that whenever we had something like, we draw, like, the outer region is going to be the upper function, right? And the lower function is going to be in a radius. But here it's opposite. Like here, if you draw a line toward the right side, outer radius is going to be the right side top, and the inner radius is going to be the bottom one, right? If you draw a line, like, whenever we have in terms of dy, if you draw a line from this y-axis, wherever it touches last, that's going to be the outer radius. Wherever it touches first, that's going to be the inner radius. And we know the function of this outer line is 2y, so that's going to be the outer radius. And this equation of this graph is y square, right? X is equal to y square. So this is going to be the inner radius. So let's go ahead and plug it in this equation. So here we have phi going from 0 to 2, outer radius is 2y, and we found out inner radius is y square dy, right? Now we can integrate this one, and we have to square it, right? This is r out square, r in square. So let's square this one first, and if you square, this is going to be 5 y from 0 to 2. This is going to be 4y square minus y power 4 dy. Now let's do the integration. If we do the integration, this is going to be 4y cubed divided by 3 minus y power 5 divided by 5 going from 0 to 2. Now let's go ahead and substitute the values. So first one, we have 5 times 4, and this is going to be 2 cubed divided by 3 minus 2 power 5 divided by 5. And if you substitute 0, that's going to be just 0. So we can just substitute 0 right here, it doesn't change anything. And let's calculate this one. So this is going to be 5. 4 times 2 cubed is going to be 8. 8 times 4 is 32. So 32 divided by 3. And we have 2 power 5, that's equal to 32 divided by 5. And if you see, we have 3 and 5 in the denominator. We can take 15 as our common denominator, right? So if we take 15 as our common denominator, this one will be multiplied by 5. 32 multiplied by 5 is going to be 160. And then 32 is going to multiply by 3. That's going to give us 96. And if you notice, that's going to be 64 over 15. So the final answer is going to be 64 pi over 15, and that's going to be the volume of this shaded region. I hope you guys find this video helpful. See you next time.